Let me take a moment to show you how to properly load the totes for a refrigerated, frozen, and ultra-cold specimen, as well as blood transportation. We're going to use the small tote. If we're going to put a frozen specimen in the tote, we recommend that you freeze the specimen prior to putting it in the tote. The PCM will freeze the specimen, but there's only a finite amount of energy in each PCM, and we're needlessly using it to freeze the specimen. So the frozen specimen goes first into the tote, and then you put the frozen PCM, which is either the PC-7, PC-16, or in this case the PC-21. With the small tote, we recommend one 3-pound unit on top of the specimen. Zip it up. You're ready to go. Next, let me show you how to properly use the small tote to move refrigerated specimens. The refrigerated specimen, once again, should be coming out of a refrigerator. The PC0 will bring them down to refrigerated temperature, but you're using up energy that could better be used to maintain a longer duration. The 3-pound PC0 is put on top of the specimen and zip closed. You're ready to go. Next, we're going to use the small tote and set it up to transport blood. In the United States, blood must be transported at 1 to 10 degrees Celsius. We're going to open the small tote. We're going to put the blood inside the small tote. And the difference with the specimens, we're going to put a custom insulator into the small tote to separate the PC0 so it doesn't touch the blood and make it colder than 1 degree. And put the 3-pound PC0 on top in the small tote. Zip it up. You're ready to go. Let's talk about the special case of allografts. In the United States, allografts must be maintained at -21 degrees if we want the possibility of placing them back into long-term storage if we don't use them. The allograft, after being placed in the tote, we add the -21 degree phase change material, and we recommend incorporating a data logger so that we can prove that the allograft was always maintained at less than -21 degrees. Close up the tote, and you're ready to go. With the medium tote, the same 3-pound PCM unit is used. Now, there's no reason you can't use 2 3 PCM units if you need a longer duration. What we try to do is maintain the units as light as possible. The same insulator is used in the medium tote as those used in the small tote. With the large tote, the procedure is basically the same, except different size PCM. Depending on the duration that we desire, we either use the 2.5-pound or the 4-pound PCM, one above and one below the specimen. So we put the PCM on the bottom, we put the specimen on top of the PCM, and then a PCM on top. If we want to maintain frozen PCMs, we either use -7, -16, or -21. If we want to use refrigerated PCMs, we use PC0 above and below the specimen. The large tote is capable of transporting 24 500 ml units of blood. The loading process is the PC0 goes on bottom. Again, you don't want the PCM touching the blood, so the custom insulator goes on top of the PCM. Then the blood goes in, all units of blood, whether it's 250 ml or 1000 ml or 500 ml, followed by another custom insulator, and finally a PC0 on top. There are 2 size PCMs that will fit in a large tote, 2.5-pound and 4-pound. Depending on the duration you are trying to accomplish, you can use either 2 2.5-pounders or 5-pound totals, or 2 4-pounders or 8-pound totals. Our goal is to maintain the tote as light as possible. Completely loaded with 24 500 mLs of blood, 2 4-pound PC zeros. This tote still weighs less than 50 pounds. Let me take a moment to discuss the large and small tote blood transportation summary chart, which is available to you in the brochures, the PowerPoints, as well as this video. Let's use by way of example test 12, large tote. 8 pounds of PCM, PC0 was used in the test. The test lasted 13.63 hours 1 to 6 degrees and 31.43 hours 1 to 10 degrees. The importance of those temperatures is 1 to 10 is the requirements in the United States for transport of blood. Any deviation outside of those normals in the blood can't be used. The 1 to 6 is the storage of blood. So we provided you both time frames. Depending on whether the tote was in extreme temperatures, such as in test 8 and test 7, or whether the tote was opened, test 9 and test 10, will depend on the duration. And you can see how each various change has an effect on the duration. In the small tote, you can see that in test 33, it lasted almost 16 hours. And depending on extreme temperatures, the same deviation. Extreme temperatures, opening and closing, will all affect the duration of the precise temperature range. So whether you're transporting refrigerated, frozen, specimens, allograft, blood supplies, or organs, TCIP makes the proper size and the proper temperature to get the job done.